Hey guys, welcome back to my YouTube channel Humanist Coming Studies. Here I Vrushika Rana will explain concepts of chemistry, class 12 in amazing ways. So stay tuned with the channel and please like and subscribe, share and subscribe for others also. So today we are going to have the formula of a compound and the number of voids free. So it is a topic, right, that we have already discussed for number of close packed structures, or you can say number of close packed sphere. So the formula that we are going to use is we have seen in our earlier video this, as I have told you to mark important for the MCQs, right? So I have a video with your textbook example 1.1 and 1.2, right? So close packed structures, it is going to be n. If I'm moving for octahedral voids, then also it is n, right? Here a number of close packed structure, we are saying that it is n. So for octahedral voids the sphere remains same, but for tetrahedral void the sphere becomes twice. The spheres become twice, right? Many of you are having the problem, are having difficulty in remembering this, because when octahedral voids many of you are writing that it's 2n, and for tetrahedral many of you are writing as the simple trick to remember this, that you are going to remember this t, that is tetrahedral, TET. So if you can see, you are having 2 times t in your tetrahedral voids, 2 times t in your tetrahedral voids. So as you are having your 2 times t, it should be my 2n, it should be the 2n. But yes, if you are saying for number of close packed spheres, it is going to be for octahedral nothing is repeated, right? Nothing is repeated, so I am having it as only n. If you can see, again if you want a trick, you can't have such trick, but yes, AA and here also AA, right? I can also have the trick with this, but it becomes little confusing, so I have made this trick to remember the octahedral as well as for tetrahedral also. So yes, let's move to example 1.1. So 1.1, the example says that we are having x and y. X is having as cations, whereas y is having as anion. X is having as cation and y is having as anion, right? And it is said that X is having the CCP structure. CCP is nothing but it is cubic close packed structure, and anions, that is Y, is having all tetrahedral voids. So tetrahedral voids is having 2, right? So first we are going to see this. First we are going to see this, that is my X. So for X, what you can see, it is having CCP, right? So for CCP, as we have discussed earlier, that cubic close packing, HCP, that is hexagonal close packing, or FCC, that is face center cubic packing, right? Face center cubic packing is having the number of atoms present is 4, right? Is having number of atoms that is present is 4, and so this is in a very use here. So yes, for CCP I am having 4 atoms, so for X I have made your ratio, so it is 4. Hope you understood it, how I return X as a 4. So next, proceeding ahead, for Y, how I returned it. So it is all tetrahedral voids. So tetrahedral voids is nothing but it is 2 times number of close packed structure. So number of close packed structure, that is 4. So 2 multiplied by 4, which becomes 8. So here number of atoms is going to be 4 and Y, that is 8. So if I am taking 4 as common, it becomes 1:2, right? 1:2. So you can write X as 1, Y as 2. So you can write it in such a way. I hope you cleared this. I hope you cleared this. The another way that you can have this. The another way that you can have this is nothing, right? The another way that you can have this is nothing but if you are having tetrahedral which becomes octahedral, right? So tetrahedral, which becomes 2n, and octahedral, which is n. So tetrahedral is going to be the 4n. So here x is to y. So what happens? X is going to be 4, right? If I am taking n as 4 also, right? If I am taking n as 4 also, because closed packed structures are nothing but they are your n itself, so it becomes again 4. So here it's 1:1 and it becomes xy2. How it becomes xy2? Wait a minute, let me show you. So yes, how can I show you that? Here if you can see, right, the easiest way that you can have this, let me explain it to you, right? So I am here taking a rough paper for you all, right, and taking this question, right? If you don't want to use this concept, let me explain you, right? So for x, if it's cation, so if I am taking x as 1, right? So what is going to be the y? Whatever here, whatever is given, it doesn't matters for me, right? It is not going to be matter for me if I am taking x, which is cations, as CCP. If I am taking x as 1, so why it is said, for tetrahedral voids, so it is going to be multiplied by 2. So y, which gives me y, which is for tetrahedral is nothing but it is 2n, so it becomes 2 multiplied by 1, which is 2. So in this way also you are going to have xy2. So I hope you understood this. The first method that I have shown you, that we are going to use the concept of, we are going to use two concepts for my first method, right? For first method I am going to use two concepts, but here only the concept of tetrahedral and octahedral, only this concept is needed here. Okay, I am going to show you this type in example 1.2 also. So let's have a look on it. So yes, we are having example 1.2. So for example 1.2, it is said that I am having a and b. So a is given that it is 2/3 times to that of the tetrahedral voids, and my b is given that it is having HCP, and I am asked to find the formula of the compound. So you can find it with two different things. Okay, the first method, right, which consists of the required things, that is going to be the number of close packed structures also, and the number of atoms that it consists. And the second trick consists nothing. Second trick only consists number of close packed structures. So it is say 2/3 of tetrahedral void. So first it's needed for us to see how the number of atoms this consists. So as it is HCP, CCP and XCC, all of this having the number of atoms as 4. All of this three having the number of atoms as 4. So what we can do is 2/3 multiply by, right, and it is tetrahedral, right? Here tetrahedral, which means nothing but it should be my 2n, right? Tetrahedral is 2n, so 2 multiplied by n, and here is 4, so 2 multiplied by 4, right? So it becomes 2 4s are 8, 2s are 16, which is going to be 16:3, and this HCP is going to be 4. And if I am writing in the ratio, here it's a and b, so a is to b, a is 16 divided by 3 is to 4. So what I am going to do, 16 and this 3 goes here, so it becomes 12. So if I am taking common 4, so what it becomes, 4:3, that is a4 and b3. The next thing, right, or you can see the next method, or you can see the next trick, by with the help of which, right, we can proceed is, right, let me show you within this paper itself. Okay, so yes, I am given for tetrahedral void. So yes, here for HCP, if I am taking HCP as 1, so here let me write B, it is HCP. So if I am taking HCP as 1, so what here it becomes, so here instead of tetrahedral voids, what I am going to do, so I am going to write 2 divided by 3 multiply by tetrahedral voids. Tetrahedral voids is 2n. So this is going to be the n. 1 is going to be the n for me. So here it is going to be 2 multiplied by 1 because it is 2n, right? So what it becomes, 2 2 is 4 divided by 3 is to 1, right? So what it becomes, a is to b, that is 4 divided by 3 is to 1, and it will give me a 4 b3, where 3 from here the 3 goes here, and this is going to be the answer, the same answer, right? If you can see, right, I have matched the both answers are going to be the same, either if you are doing with this method or either if you are proceeding with this method also. I hope you understood the easiest, most important these two tricks. You can have any of the two tricks that you want, you can apply any of the tricks that you want. So stay tuned with the channel and please like, share and subscribe, and have a great day. See you soon in the next video.